So I'm going to be talking about how to find the area between curves. And to do this, you're going to use this function, a equals b of a, and then f of x minus g of x, which is your two functions. You're going to subtract them and then find the derivative. So the steps to do this are, first, they're usually going to give you two different functions. So you're going to want to draw the graphs to see what they look like and to see which one's on top, kind of what area you're going to be finding just to visualize it. And then next you're going to determine if you need to do it in terms of x or y, so either dy or dx. So if your graphs are vertical, you're going to use dx, and if they're horizontal, you're going to use dy. And you can also do that through graphing to see what they are. And then you're going to find the boundaries or intersections, which is your a and b, and that's the integrals you're going to use to where the function's bound. And then you plug everything into the equation and integrate/evaluate. So I'm going to do an example of what this looks like. So we're going to use the problem, find the area of the region in the first quadrant that is enclosed by the graphs of y equals x to the third plus 8 and y equals x plus 8. So y equals x to the third plus 8 and y equals x plus 8. So I already went ahead and drew it right here. So this is what the two graphs look like. This is x plus 8 and this is x to the third plus 8. So the problem asks about only the first quadrant, so we're only going to be looking at this. And then this little area is what we're going to try to find. So as we can see, the straight line, which is x plus 8, is on top, and x to the third plus 8 is on the bottom. So that means in our equation, we're going to use this as the f of x and this as the g of x. So we're going to subtract this one from this one and then integrate. And the next thing you have to do is find your boundaries. You can kind of see on the graph because it's a simple functions, but if they weren't, you could set them equal to each other and then find the common variables that way. So for this, it is going to be 0 and 1. So now we're going to go ahead and plug it into the equation. So area is equal to 0 and 1, which is our b and a, and then our f of x is going to be x plus 8, and then minus x to the third plus 8. Fix my parentheses. So that's what it's going to look like, and then you're going to go ahead and distribute the minus sign. And then simplify, so the 8s are going to cancel out, so you're left with negative x to the third plus x dx. Forgot to add that. So now you're going to go ahead and find the antiderivative of this. So you're going to add 1 to the exponent and then divide by whatever the new exponent is. So that's going to give you negative x to the fourth over 4 plus x squared over 2. And then you're going to integrate with your boundaries, which is 0 and 1. So when you plug in 0, it's just going to be 0. So we're going to go ahead and move on to 1. If you plug in 1, it's going to be 1/4 plus 1/2, which is going to give you your final answer of 3/4. So the area between these two curves is going to be 3/4. So that is how you find that.